So as I wrote this thousands of pages of code, I was saying to myself, well, you know, you want to make this readable, you want to comment it, you want it to maybe be typesettable, but I had no idea how to do it, and I didn't want to use web tools because web places a barrier to what I want to do. Now, I've known about web since I picked up Don's paper or memo, the web system of structured documentation in 1983, which I've had since then. So as I was coding this TeX library and being infused with what Don's did in his work, and knowing for the past 2 decades that I didn't like literate programming, I at least commented it in a way that was sort of structured, that was visual and sort of ASCII-arty and so forth. So then in the last year, I've written this program that actually codifies some of my informal rules, and I call it literacy. And so it's the flip side of what's the right word? Ontology recapitulates phylogeny or something. Anyway, whatever I'm doing that's kind of duplicating what Don did. But so literate programming, as was mentioned earlier, the idea was introduced by Don 30 years ago. It started out as an amalgam of Pascal and TeX with an added layer of special web markup commands, and there's extra tools you have to use. And then it got converted into being useful for C compilers. And then Tom Rokicki wrote Web to C, blah, blah, blah. Everybody knows this. And TeX source code is still written in web in the Pascal variant of it. And it solves some good problems. I mean, it's even what Pascal was at the time, and you know, it creates formal conversion and rearrangement of pseudocode constructs into code, and which create, you know, using typesetting is a good thing because typesetting is for imparting meaning via, you know, graphic means. It allows code and documentation to be more easily synchronized, and in web, what he does is he migrates, he wants to be able to introduce variable names and features and so forth later on from where it's actually going to end up in the final code. So web migrates code lines pretty much upwards. I mean, it can move them around anyway, but for the most part, it seems to move it upwards. So you declare a global variable down on page 900, and it's actually going to end up in the code back up higher where global variables need to be for the compiler's sake. And it solved the preprocessor problem in Pascal and created a simple syntax for quoting code in comments. And it treated a large program as a piece of literature worth reading, of course, only if one writes well. And it adds some document features like a table of contents. But most programmers don't use web or C web. Markup, in my opinion, is terse. It's undiscoverable. I can't understand it after a long period of being away from it. It's not free form. You can't use white space very easily. It requires, and this is one of its key flaws, it requires rather than gently permits the programmer to think in several languages at once. From my personal point of view, the web tangle weave bootstrap has constantly made my life. Every time I sit down and say, okay, I'm going to see if I can use web weave tangle, and I try to compile it, well, then I don't have a Pascal compiler. You know, it just goes on, and it keeps users away and so forth. The use of global variables is fostered by this type of programming. It actually turns local variables into essentially global variables because you don't know what they mean, you don't know where they came from, you just see these variables being used, and of course in Don's programming most variables are integers anyway, but complicates and slows down the edit, compile, test cycle for working programmers. When you're in the zone, you want to think in one language, you want to be just coding away and getting your ideas down into that logic. I don't like the code being typeset as mathematical notation. I know that that's part of the computer science sort of literature way of doing things, but I want to just see it as code because that's how I view it. And so a lot of literate programming solutions should really be in the computer language and in the IDE editors use, and some of them have, you know, basically they're solved at least in C. And everybody knows about this problem. There's websites devoted to it. So what I want is sweet incremental simplicity, reasonable power, but I don't want to be locked into a bunch of tools that if I don't have them in the future, I can't do anything. I want to invert what everybody here is used to. I want my documentation derived from the source code. I don't want to create my source code from the documentation. I understand that there are efficiencies from getting rid of all the comments, but I really don't think it matters. The amount of time that I have lost trying to find out and remember whether free can take a nil pointer is huge compared to the amount of time all the compilers that I've used over the years would have to waste for one comment next to that header free in the header file that says nil pointer is legal or nil pointer is not. So I'm a firm believer in keeping comments with code, and I don't think stripping comments is particularly useful if a human is ever going to read that code again. So I want documentation to be dependent on code. And I want only a few easy to remember commands. I don't want pretty printing unless I ask for it. I want as arbitrarily long lines. Editors these days can deal with them pretty well. I want defaults for immediate success or good enough solutions. I want error messages, of course. I don't want to fight against LaTeX. I don't want to be forced to use LaTeX. I want just a simple set of commands that I know are going to work, and then take care of the syntax errors that will inevitably occur if I were to use LaTeX. But I want LaTeX power if I need it, and I know what I'm doing. So, and of course, I want to get a literate, well-typeset exposition of the program. And so what literacy does is it takes a C source file or any source file in a language that uses C-style comment syntax, and it outputs a LaTeX file. It's a command line program. It's written, it's about 6,000 lines of code, another 6,000 lines of literate commenting. The first 2,000 lines are its own user manual that will typeset. It will typeset itself. So this program, unlike JSBox, it does eat its own dog food right now. It's very fast. It supports multiple input files and options in one identification, but I'm currently struggling with what to do for whether it's multiple files and multiple output files or multiple files and one output file. It uses some standard LaTeX packages. It does not use the listings package, and it only supports C-style comments, but those are the languages that rely on those, and it handles a lot of obscure cases. So comment delimiters are for the benefit of your compiler, and they're for your benefit when you're the source code author, but only once. After that, they're a pain. They get in the way of reading. I just find them, I just can't stand them. So I want to get rid of them because they're just syntactic noise, and when you have a syntax coloring editor, you don't need them technically, and I glean a lot of information by scanning the left side of my code. I don't want to see all this stuff there. So literacy gets rid of all delimiters unless doing so would introduce ambiguities. There are certain cases where you don't want to introduce ambiguity, for instance, in a pound define statement. So that means you have to use different styles for different kinds of comments, whereas you just use the standard verbatim style for your code. So literacy actually focuses almost completely on what it classifies as a comment and not on the code itself. So, there's a taxonomy to the two kinds of comments. Each one can be embedded in the other, so those are pseudo. I call what most people call line-ending comments, I call them gloss comments, because gloss is a word that represents, a short statement about something to its left. And then I just read a couple of weeks ago that Swift has implemented nested block comments, so I don't support those right now, but it shouldn't be too hard. Then there's, for each of those cases, so I've gone down and tried to figure out what all of the taxonomy is for different styles of comments, whether there's a block comment on one line, multiple lines, whether it's preceded by code, whether code happens after it, or whether it's right in the middle of code, et cetera, et cetera. And then there's what I call simple block comments, where the delimiters are in their own lines, and that's what I've sort of evolved in my own commenting style for years. And I actually comment with them way over on the right, which I really like because all that noise is out of view. I don't have to think about it. I can see the comment, and usually in a syntax coloring editor, it's obvious that it's a comment, and even without that, it's still obvious. So literacy works to regularize the comment stream, and it recognizes things like this, and it tries to replace them. Eventually, it'll try to replace them with rules. Right now, it tries to get rid of all that cruft. It only supports one part of the line being code and one part being comment, even though that is not always true, but there's ways to fix that. It honors line continuation in comments, but not in code. Let's see, what else? Basically, you can embed commands in your comments that literacy recognizes, and it either transmogrifies the argument to that command or just executes the command depending on what the command is. And it just lets TeX merge comment paragraphs that are separated by divided lines into paragraphs in TeX. And so I basically have two types of styles, but this can be generalized. So basically, I get rid of lines that have the delimiters on them, and then I allow pure TeX code to be inserted with using this delimiter, a bar and an ampersand. So you can do that. You can insert TeX code on one line, or you can insert an arbitrary number of lines into the eventual LaTeX file. Then I have what I call supergloss comments, which basically delete the comment from the Typeset version. So three slashes in a row means the comment is gone from your Typeset version, or 2 slashes and asterisk is the same, but it doesn't conflict with, say, Doxygen. Or if you want it to remain a blank line and there's nothing else on the line, you can use a pair of backslashes and a dot. So here's just a few of the commands that you can embed in any comment to basically cause LaTeX to use emphasis, bold, math display. The text command basically prevents a short line from being treated as a title of a section or a chapter, and then the table of contents is just a wrapper around the table of contents macro for LaTeX. You have to use a pair of braces, otherwise it's just a comment. Using the same syntax, the vertical bar, except I'm using fancy verb, but unlike fancy verb, in literacy, a vertical bar between any character between two vertical bars is verbatim, no exceptions, no escapes. So a triplet is a singleton, and you can have a backslash, you can have an ampersand, and if you have just two, then it's an empty verbatim quote, which actually proves useful in a couple of situations. Finally, in a single line, these are executable commands that do things like define macros, or instead of putting every type name in your comments, you can actually in one line declare a set of type names that'll be automatically verbatim when literacy finds it in a comment. So you don't actually have to go and surround every instance of some name of a C type or whatever. It doesn't parse the C code. Yes, it could, but that's a hard problem I don't want to solve right now. So you can have your own macros. You can reserve space using need lines. You can skip over any set of the lines, either counted or uncounted, if you don't want those to be in your typeset version, for instance, old code that just shouldn't be there. You can create a macro which represents any set of lines called a line group, and you can just start saving into it until you say done, and you can append to it later on if you want to have disparate lines in the source file go into this macro line group. And then later on in the file, or maybe even in a different file, you can insert that set of source code lines in the proper pedagogical place. So what is going on here is the opposite of web. What I'm doing is I'm allowing you to move lines in your source code forward into the typesetting version for pedagogical or top-down explanation purposes. And then there's managing some of the options list. So for instance, you can have you would say every instance of the word entry is going to be automatically verbatim. It will actually automatically verbatim plurals of that, since I found that to be something that I've done a lot in my own commenting. You can define a macro name, but because all these commands have braces around the first argument, you can actually define a macro name and whether or not it's going to eat one space on either side of it. So that actually proves useful in some cases, because otherwise there's some problems that come up. But it just allows you to solve some of these problems. And they're pretty simple to understand. Start skipping at this line and continue until the count is ended. It's great for suppressing, say, C prototypes, which are solely for the benefit of the computer or the compiler, and not for the benefit of the reader at all. So I get rid of prototypes or whatever. And there's some interesting hacks you can do, like you can use the skip command in a comment with a preprocessor in C, so you can actually have actual code from any language typeset verbatim in the eventual typeset document. And I use that a bit in my manual. And then this is about, I take this and I say, I don't typeset this here. I'm going to save it in a macro called foobar stuff, and then later on I'm going to insert it wherever I say insert foobar stuff. Interestingly, that also undefines the macro, so you can't insert the same code in more than one place. I think that's a good idea. I don't know, but I think it's a good idea. Then you can, inside block comments, you can create visual dividers. So you can say this is a part, a chapter, a section, subsection, etc. Or you can just create a blank line, which TeX would normally be used as a paragraph separator, but you can say I want a verbatim blank line at any spot by using a lone period. So those are various types of dividers. You can tag them with any characters that you like, and so that they're searchable, and that actually declares them as, please look at the next line, take it as a title, and put it into a table of contents. So it works pretty well. And then there's a special comment that says, don't typeset after this, so that you can place a manual or README portion of the commenting in the beginning of the C file, and then just quit. Then there's a bunch of command line options and blah, blah, blah. And so what do I have left to do? Well, I output a custom preamble that I hacked together. I have no idea what I'm doing. I've never written a package in LaTeX, but it seems like that actually would be a good solution. I haven't quite figured out what to do about concatenating input files and what it means to transfer lines that were in one file to another file, and how you can show that the line numbers are different, but I haven't solved the problem of showing where those lines came from. Sharing a macro dictionary across files, so you can have one declaration of what should be verbatimed and then just sluice the rest of your files through it. It's mostly working. And a bunch of other stuff. I don't have indexing working yet, and of course it doesn't work on other languages in their comments. So let's just show you what the output looks like. I'm going to run literacy. I just ran it on JSBox, so let's click in here. Let's see, where is that? Okay, so let's. Okay. All right, let's run that again. Okay, so it gives me a bunch of error messages, which are deliberate because I'm using literacy.c as its own test suite. So I put in a bunch of lines that do crazy things, like one line has every printable ASCII character in it, another line has a macro which it has its tail recursion, so it overflows, so there's a limit on how many macros you can apply to a given line. So that creates a LaTeX file, so let's go and format it, and let's look at literacy.c, and let's typeset that. It's about, and so you get your source code. Is that visible? Gives you a title page. It's using book, so it's giving you an extra page here, which I don't like, but I don't know how to deal with that very well. And this is all typeset based on what's in the comments in the C file. So there's the table of contents that is based on the tag dividers, and this is, telling you where pieces of snippets and subroutines are of code. Here's the actual meat of the program where it parses all these different situations in a line, and outputting, so forth. There's a line window. Literacy operates on an arbitrarily long list of lines. It operates on a line at a time. It transforms the line partially, and then it operates on a window, so it can actually go through an entire comment, no matter how long, and analyze it, and look for asterisks, or figure out various global things about the comment and make decisions about that. So there's an introduction. Notice I have footnotes, using the footnote macro and so forth, and all of this stuff that LaTeX has is all available. So this is all the README portion. It's basically the manual. Here's a synopsis of the commands that I just explained, and it's it's only 2 pages. That's the first thing that any user is going to want to look at in a README file. And then I go and talk about there are various types of comments, what it does, and so forth. It keeps going and it explains all the commands. And let's see, let's keep going down here. That explains divider patterns. You can use any tag pair of characters you want to mark that divider pattern as something that's searchable in your IDE editor, and explain that. And so it's just basic, and it's not super generalized, but then at the end of the README section, I don't normally typeset this, but I did this for pedagogical reasons, and then the code starts. Okay, and here are the line numbers for the code, and my comments, gloss comments are in italic right now. They don't have to be, but that's what I thought was useful. Everything in code is in the verbatim font, and it doesn't mark the lines that have comments on them because that's useless. And so I'm just, to get this to look nice, I have to actually, go back to my code and organize it. Just like, literate programming is supposed to make you do that up front, but nobody wants to do that up front because you're in the zone. You got to get stuff working. You have to typesetting your code to turn it into literature is great, but it doesn't mean that the code was literature to start with. So I'm not a proponent of literate programming, as you can tell. But I think this looks really good. I would want to read this. I like reading other people's code. I like reading well-typeset stuff. And I've gotten a significant amount done completely automatically here. And the rest is tedious. I have to go in and make sure that I'm verbating this. And so when I read through this, I'll eventually find bugs and so forth. And so this is the entire program, and I basically have a little explanation of what each subroutine is, not unlike what tech.web does. And I can run this on tech.web, what is this? Let's go and change this back to typesetting 2,000 pages of JS box. Okay, let's run that again. So there's that, and if I go to TeX Shop and open up the output of that, okay, there's that, and we'll typeset that. It takes a little while to typeset 2,000-page PDF file.
This is TeX, not JS box.
What's that?
This is TeX, not
No,
JS.
this is JS box.
Ah, this is JS box.
Okay. And so there's my table of contents. It's going to go on for 30 pages. And so I'm slowly working to fix all the bugs because I actually didn't know what I was doing when I started this. Let's make this a little bigger. So I'm revealing my coding style here, but so here's a subroutine does, and then I don't have any syntactic noise. I can see what's a comment and what's not. See if I can find an example of a pound sign statement that I can typeset the header file. There's some weird some weird problems I haven't solved yet, but okay, I'm done. Anyway, so I can typeset JS box now, and I'm slowly going through it every couple of weeks. I stop and I go through the next chapter, and I take out all of the verbatim quotes that I added originally because now I don't need them because I've got a program that will auto-verbatim for me, and I clean stuff up, and eventually I'll be done. So at the very least, maybe I can sell a book of my source code for a tech interpreter.
So we got time for a question or two, either on literacy or JS box. All sets up.
Now you demonstrated that JS box runs quickly on this computer, but how well does it actually do on embedded devices where a lot of people will be reading ebooks?
Probably depends on how much memory they have. Depends on the library uses less than a megabyte to set itself up, and then when it builds an interpreter, all memory is allocated dynamically. So whatever the system has, it'll deliver it, and things may slow down. If there's like a virtual memory system, I don't know whether an iPad, so it's a question of what, how that operating system deals with it. I haven't tested it yet. The idea on this is to create ebook reader on the iPad, but I'm not going to do that. So, any other questions?
I have a question.
Oh.
Okay, traditional question. Are you going to put literacy on C10
Yeah, I want to do that also.
Yeah, because it seems to be an interesting tool. I really would like to
think so.
use it. Is it publicly?
Not yet, because it's still got some problems with it. And I just want to.
He's teasing us. He keeps
I need to figure out one problem that I don't have to. I can take code out and it'll be ready. It's ready for prime time. I mean, it works. Obviously, it works. So.
I really would like to use it in some code where I cannot use literate
I
programming.
want to get Carl to document K-path search.
I actually start, well, that's another whole story. Paula, you had one question for Doug?
It was his question.
Oh.
So one of the things that the web system offers is an index with variables and links to where they're defined and so forth. Does literacy offer?
Yeah, it should. I just haven't gotten to it yet. I mean, all it does is create a LaTeX file. It's what, whatever is in the preamble. But all of that really should be in a package. It shouldn't be where.
But literacy doesn't parse the code, right? So
Literacy doesn't parse the code.
So you're not going to create it.
But one thing it does is it looks for C strings and or C character constants, and it puts in typographic quotes around them, because I can't stand seeing that in published papers where people have forgotten to do that. But that's the only thing it changes in the code.
You can actually do it in LaTeX. You can just output with the traditional codes and make a LaTeX command which does this. There are several packages.
I'm sure.
Well, let's thank Doug.